Okay, this is lesson 7.4, which is factoring complex quadratics, difference of squares, and perfect squares. Okay, so we're going to go ahead and factor this expression using the box method, but then also using that to inform us what the difference of squares method is. So if we take a look, this is 4x squared minus 25. It's missing a term of the standard form. So we have 4x squared, which is the ax squared term. We have the negative 25, which is the c term because there's no variable. So we're missing the bx term. So what we'll do is we'll go ahead and add it in, and we're going to add 0x into it, because there are really 0 x's in this equation, or sorry, this expression. All right, so first term, first box, last term, last box, then a times c goes in the t-chart. When we write down the factors of 100, there's a lot of them. 10 and 10, 2 and 50, 20 and 5. There's a lot of them. But what I'm looking for is two numbers that combine to give me 0. So that's 10 and negative 10. So I throw a positive 10x in one box, negative 10x in the other box. I'm going to factor the GCF here, which is 2x. Here is 5. Here, 2x. Here, which is negative 5. So if we were to factor this, it equals 2x minus 5, 2x plus 5. Now, how does that relate back to the original? If we take a look at this term and these two terms, okay, 2x times 2x is 4x squared. If we look at the last two terms, negative 5 times positive 5 is a negative 25. So what happens is the first term gives us the first term, the last two terms give us the last term, and then what happens is, since these signs are opposite, that middle term cancels out. That's what the difference of squares is. So if we have something in the form a squared minus b squared, it will always be equal to, so it's a times a, it's b times b, but one's positive and one's negative. So taking a look at this one, 4x squared is 2x times 2x. Negative 25 is 5 times 5, but one's positive and one's negative. That's how you use the difference of squares. But you don't have to. You can always just use, you can add the 0 term in. Let's take a look at perfect squares really quick. Perfect squares are a little bit different. Let's go ahead and expand this one. X plus 3 times the quantity x plus 3. That's going to be equal to x squared plus 3x plus 3x plus 9. So that's equal to x squared plus 6x plus 9. X minus 9 is going to be x squared minus 9x minus 9x plus 81. So that's x squared minus 18x plus 81. So looking at the pattern, if we have something in the form a plus b squared, that's going to be equal to, let's see, this term, x became x squared, x became x squared, so it's going to be, a is going to become a squared. Then positive 3 became a positive 9, negative 9 became a positive 81, so it's still b squared, a squared plus b squared, but the middle term is 2 times a plus b, a times b. So 3 times x is 3x. Negative 9 times x is negative 9x. And there's 2 of them. So plus 2ab. How do we use that in the reverse? If you can recognize that this last term is something squared. So the last term is 5 squared. And the middle term is 2 times 5. So 2 times 5 is 10. Then you have a perfect square. X plus 5 times x plus 5. Let me show you one more. X squared plus, let's say 16x plus 64. The last term is 8 squared. Is the middle term 8 times 2? It is. So this is also a perfect square. But, oops, you don't have to do that. You can always just factor as normal.